So 4.2b of college algebra, and I'm on page 366, and they give you an application there. They give us a formula that you should all be familiar with from past math classes, and there it is. That's the formula for compound interest, and this number right here is the amount of money that a principal, this amount invested, will grow to after T years at this interest rate, okay, compounded this many times per year. So if it was, the question was, or involved a time period that it was compounded like semi-annually, this n would be a 2. If it were quarterly, this would be a 4. If it was yearly, this would be a 1, and that would be the interest rate, principal, and at the end you get a dollar amount of how much money you have as an amount. Okay, so this is the principal that you invested plus the interest that you get back, and that would give you that amount there. So that's what they're doing there on that page 366, but what we want to go into is 367, where we are using the letter E, or in this case the number E is what they call it, because it is a number similar to 2.718, etc., etc., etc. It's kind of like pi. It goes on forever. It's a decimal, and it is a constant. Usually what I have students do, you've got a key on your calculator that'll put that in there, but if worst comes to worst, usually have you guys write just 2.718, and you know, that's just kind of the rounded off area there. If you want to know where that number E comes from, top of page 367 gives you the theory behind that. When you go to page 368, it gives you graphs using exponential functions with base E. Now this is very similar to what we just did when we had a f of x equals 2 to the x power. When we added a number to our x, or added a number to this, or changed the sign to a negative, or put a minus in front of there, we shifted left, right, shifted up or down, we reflected across the x-axis, we reflected across the y-axis. The same is true when you have a function of e to the x power. So if we have a function of x, e to the x power, we get a graph that looks a little bit like this. Looks like e to the x, or e to the 2x power, or yeah, kind of looks like that. When this becomes a negative, we get a graph that changes to go this way. Okay, so it flips across the y-axis. If we were to put a +1 on that, the y-intercept here would jump up 1. Well, you know, the entire graph would go up 1. So it's, you know, the same rules that we used before as far as when we had f to the 2x power. I mean, everything works the same way. So if you just follow those, you know, you're doing well. So if you have, for example, compare f of x to the e of x, and let's say that we put this as an x minus 3 instead. That would move to the left 3 units. So if we put a negative in front of the e right here, that would cause it to reflect across the x-axis. The negative up here would cause it to reflect across the y-axis. And one of the things that they're introducing here is the idea of shrinking and expanding, or getting bigger, whatever. And that's when we put a number in front of the exponent there. So if we have a number here like a 2, that is going to give me a horizontal shrinking. So my graph, instead of being like this, may be like this. Okay, so it just, the distance here gets narrower if there's a number greater than 1 there. If there's a number between 0 and 1, it's going to stretch. It's going to get bigger. So if this were e to the 0.5x, it's going to stretch. It's going to elongate. So it would be more like this if that number is somewhere between 0 and 1. So for the most part, it's the same rules that we used earlier as far as reflecting over the x and y, whether it's going to shift up or down, and then the new thing that we introduced here was if there is a number in front of the exponent x. If it's above 1, it's going to cause my graph to shrink. If it's less than 1, it's going to cause my graph to stretch. Okay, so that's pretty much it as far as 4.2 is concerned. Maybe it'd be good if I just went over real briefly a reminder of what all the signs do, and so we'll do that as an ending to this lesson. Okay, so I just wrote this equation here, so let's just see what happens for it. All right, so the 1 tells me that I'm translating up 1. Okay, if it was a minus 1, it would be translating down. And sometimes the book writes it this way. I prefer to write it this way with the 1 there, because then I've got the plus sign to remind me what's going on. Okay, so let's keep going. The minus sign that is right here tells me that I am reflecting across the x-axis. This minus sign tells me that I'm reflecting across the y-axis. This number tells me that I've got a horizontal shrinking of my graph. And that's about it as far as that problem is concerned. So if I were to have this number, if I would have had a number like a minus 3 here, that would mean that my graph is shifted left. Now let's put a plus sign. That plus sign means that my graph is shifted left 3 units. If that were a minus sign, it would mean I would shift to the right 3 units. Okay, so this one means I go up or down 1. This one means I go left or right. This one means that I shrink or stretch. This means that I'm going across I'm doing a reflection across the y-axis. This means that I've got a reflection across the x-axis. Okay, so those things all are from that equation there. So you shouldn't have any trouble with the homework. Just remember to write those down. What I would have a tendency to do is put, there's a negative in front of the base, reflect across the x. If my exponent is negative, reflect across the y. If my number is above 1, it's going to be a shrinking. If it's between 0 and 1, it's going to be a stretching. If you add a number to the exponent, I'm going to translate left or right. If I have a number added to the whole thing, I'm going to go up or down depending on whether this is a plus or minus. So all of that information can be had there. So I would write that down in your notes, since you are allowed to use your notes for the Chapter 4 test. Okay, so that's it.